Some of our key components are relays and in controls. So we've been learning about controls. These are electrical switching controls. A relay is basically a control that's energized by one voltage to control another voltage. Simple, right? Okay, so we're gonna talk about it. First one we're gonna talk about is the peanut relay. Huh?
Is it called peanut because it's small or?
It's called peanut because it's a peanut. You don't believe me? There it is. There's a screenshot.
There's no price, that's not.
Yeah, there's no price.
Well, there's a screenshot, it must be true.
It just says, something pickup, there's 23 available.
That's enough.
It's enough of that. Okay, so as we can see, the peanut relay has two sets of contacts. Those are contacts. We take our Sybil's handout and we can look at contacts, right?
Correct.
You see them? You see them there?
Not yet.
You see them there? See them there?
Yes, yes.
An NO and an NC.
Yeah.
So on this we have an NO and an NC. What is NO and NC? You don't know?
No, I don't know.
Normally open and normally closed.
Oh.
So these relays, anytime you see a schematic and a relay and it's a normally closed contact, that means it's normally closed. When the power is off, normally closed. If you see one that's open, it's normally open. Normally. So these will not switch positions until this coil gets energized. Remember energizing coils? Remember coils that get energized, create electromagnet? You forgot last week?
Creates magnetic field.
Oh, yeah.
So this actually is a coil that creates electromagnet that pulls a lever and it switches these contacts. Pretty simple, really. There's a little demonstration back there, a little relay thing, so you can look at. So these are pretty common. They're called a peanut, okay? As we can see, right there, see?
24
That's the actual
volts.
screenshot. Actual screenshot. Okay, so there's the peanut relay. So when this energizes, whatever you have hooked to 4 and 2 completes the circuit. Okay, this is just a switch. That's all it is, a switch controlled by the control voltage. Have we got that? Got that? Okay, so here it is in a schematic. Here is we'll call that the BR. There is the coil. And here are the contacts. Normally open and normally closed. You see those? Are you guys seeing that? So here is the coil on the low voltage side, because it says 24 volts right here. This is the low voltage side of that schematic, and this is the high voltage side. So the BR, when it's energized, is gonna kick on the blower on high speed. Whoa, that's practical where it comes. You understanding that? Anybody getting that?
Yeah.
Oh. The more you see it, the more you'll get it.
What?
I'm getting nobody's going. Okay, so we'll talk about another relay. This is the double pole, double throw relay. As you can see, it is double pole, double throw. Is that pretty obvious? No?
What's it now?
No? Okay. This is what it looks like on the top of that relay. You got the 24 volt, this is the coil that powers the relay. So when this gets energized, common and normally open, close. Common, normally open, closed. As you can see, here's a little schematic diagram. It's got a normally open and normally closed, and it's got two poles that are isolated.
Just pointed at you.
I know.
What?
White lady is pointing at me.
Just like that.
I thought it was gonna be big.
Okay, so this relay is called an ice cube. You guys paying attention?
Yeah, it's ice cube relay.
Ice cube.
This ice cube, this is called an ice cube relay. Okay? Why do you think it's called an ice cube relay?
Cause it looks like an ice
Cause
cube.
you can see through
It
it.
looks like an ice cube. There's a screenshot for you, right there.
Why didn't we get a screenshot of the other one?
I know,
What?
it doesn't exist.
Kicked off of it?
Well, the two-sided one, you didn't show us an example, like the screenshot.
The double pole.
Yeah,
no.
Yeah,
It's 'cause
Oh,
it's
no.
over there.
No, that's a made-up one.
That's made up.
The screenshot. was
Non-existent.
legit.
Okay,
If I
so
can't
we
buy
have
it,
ice
I'll
cube
know.
relay. Now, the ice cube relay has multiple contacts. So if you,
Connected there.
this is where you energize it. This is the, what they call the input, that energizes the coil on the low voltage side. And as it energizes, 9 makes 5. So 9 and 5 make contact, 10 and 6 make contact, 11 and 7 make contact, and 12 and 8 make contact. The normal positions is 9 and 1 are closed. 10 and 2 are closed. So you can see the little armature things right here.
So they're all
See that?
closed. Bottom.
So when it energizes, these armatures flip over. Right? Yeah. You getting this?
Kind of.
We need to go slower or faster?
Both.
Both. Okay, so these are relays, okay? We also have time delay relays. Okay, so the time delay relay is actually when it energizes on these two terminals, it heats up a coil of wire inside the relay sitting next to a bimetal. So as it heats up, the bimetal moves and it makes the contacts in a time delay fashion. Okay? So that's a contact. This happens to be a carrier specific part. Time delay relays come in different shapes and sizes. There's one there. This is also a time delay relay. It's showing you right here, the 24 volts goes down here, and your contacts are up on top. So you have a contact there, and you have it normally, it's like normally open there and normally closed there. Okay, so this particular relay is sized, or is, the part number gives me indication of, it looks like 55 seconds on and 45 seconds off. Okay, so these are pretty accurate. Also pretty expensive compared to that. That's pretty inexpensive. This is also called a sequencer, so it's basically the same thing. Your power comes in on the bottom, 24 volts, it heats up a little coil, and a bimetal snap disc pushes a plastic rod up to the top, and it makes M1 and M2, and M3 and M4 at different times. Okay, so this is used for sequencers, they call it sequences, used for sequencing on heat strips. So if you have a couple of different banks of heat strips, you don't want them all coming around at the same time, you wanna sequence them all. Yeah? Okay. But it's still a relay, right? Are you getting it? Good. There's a drawing of a sequencer. And here is a sequencer in a schematic. So if we're looking at here, here is the control part of that, the 24 volts. A little coil that heats up and moves a bimetal, and it closes this set of contacts, or it says the TDR. What does TDR stand for?
Time delay.
Time delay relay. Wow. Imagine that. So this time delay relay, as soon as that closes, it's gonna kick the blower on low speed. But you have to energize this wire here, which is the white wire. The white wire is also controlled the gas valve at the same time. Everybody seeing that? Are you having problems with schematics yet? Okay, we'll start from the beginning when we talk about schematics. Okay, so now we're gonna move on to the contactor. This looks just like that, a contactor. Okay, contactor has two sets of contacts. On this particular one, it has two sets of contacts, and they're both open. So when you energize it from here and the other side, you have closed those contacts on here. This contactor will handle up to 40 amps of current through the contacts. Okay, the relays will handle up to about 15 amps or so. Okay, but this is still a relay. Even though it's a contactor, it's still a relay. It's just a big relay, okay? You okay with that? There's another contactor there. Be seeing that?
I'm seeing it.
You go too fast, huh? Okay, there's another contactor there. Okay? Here is a contactor in a schematic. Right here, as this energizes the coil in that contactor, it closes those three contacts. 1, 2, 3. Typically for three-phase operation. So we go back, this happens to be three poles, 1, 2, 3. And this one is 3 poles, 1, 2, 3. See that? 3 poles. And here it is in the schematic. Again, these 3 contacts are closed when that gets energized. Okay? You get no response whatsoever. You guys are either lost or you're not asleep because your eyes are open. So those are contactors, right? They're just relays. Now we're gonna move on to bigger and better stuff. This is a magnetic starter. This is a big contactor. Basically, it's the same thing. It's still a relay. Okay? So the starter, what sets this starter apart from the contactor, not only is the size bigger, it's got an overload protection on it. So a contactor with an overload is going to be a starter. Okay? So this one will handle up to 100 amps on the contacts. The starter can be rebuilt. You can buy the contacts when they get worn out, pitted.
Oh, so
You can change the contacts, you can change the coil in here too if you burn out the coil. And
you
can
can
also
pick
replace
and
the-
choose what you wanna change if that one
Yeah,
turns
these are
out to burn
rebuildable.
out.
These are actually rebuildable because these are
So,
gonna be
if-
about $300 for
so
that
in the,
deal.
in the short term, it might be more expensive, but in the long term, it's a little cheaper. Or,
Yeah,
will
well,
it-
that depends on what you're on, what you're starting. If you're starting you know, like a 75 horse motor, you're gonna need one of these. You can't do it with a contactor. So that's why the starters are there. They're for higher amperage. bigger
okay,
stuff.
so the higher.
Yeah. And they have an overload on them, which makes them classified as a starter, but they're still a relay, basically the same thing, they're still a relay, they have a coil in there, and a coil energizes and it closes those contacts.
Okay.
Okay, here's another picture of one, this is another starter, a little bit more compact. This one has electronic overload, just like the last one, where you can dial it in and set it for what you want. Okay, here's one in an enclosure. Same thing. Most starters are 3-pole because they're for 3-phase stuff, which is big commercial stuff. Yeah, there's a little picture. Oh boy. So here you have a 2-pole and you have a 3-pole. So they do make 2-pole, looks like, because there's a cartoon of it.
Oh. The cartoons are always right.
Yeah. Okay, so we move on to overloads. The overloads are pretty interesting, because these overloads right here, we looked at a couple of overloads and they were electronic. These are not electronic. These are actually called heaters. And they're overloads for the starter itself. So these numbers on top correspond to a publication put out by the National Electrical Code to determine the size, the amperage of these heaters. So when those heaters, they called heaters, and this is what they look like when you take them off. It's just a little heater, current goes through there,
Okay.
and it heats up. Heats up, sits on top of that little bimetal rod. Okay, if it gets too hot, this rod will sense it and it'll open up the contacts in here. So these heaters are sized according to the amp draw of the motor that you're trying to start or run, right? So these are also sized by the National Electrical Code. Okay? This stuff is old school. I've had to change heaters out a few times, just get them sized right, and there's a certain tolerance where you go. If you got a certain size, you can go to the chart and look at the chart and see if you can go up any bigger on that, and if you can't, then you can't. Then you got something else going on. You have to change you have to change something, like the motor or whatever. Okay? That's it.
That's it.
Wasn't that exciting?
That was thrilling.
Okay. That was thrilling, huh?